prime factor trees. These are just a diagram which we use to break down a number into its prime factors. It's really, really easy, okay? Just refreshing your memory here that prime numbers are commonly used 2, 3, 5, 7, 11, 13 and 17. When under a prime number, you can divide it by 1, which gives it 13, or by itself, which gives you 1. So you have two answers there. It'll be 1 and itself. So nothing else can go into that number but 1 and itself. 5 is the same. It's every single one. That's a prime number, okay? Here's a little example of a prime factor tree. So it's asking us, they want the prime factors of 12, okay? So we draw little branches of the tree. Now, I know two numbers that make 12 are 2 times 6. Now, I've underlined this because we stop on this branch because 2 is a prime number. But we must carry on here because 6 is not a prime number. So we add another 2 branches to the tree. And to get 6, I've times 2 times 3, which makes 6. So we now have 2 times 2 times 3. So we've written it in product form, and product means to multiply. This is what you're doing here. So we're multiplying our prime numbers. Now we can go even further with this, and we can make it into index numbers. Now it's the powers of the numbers. And we do this to make the answer tidy. So for example, we've got 2 times 2 times 3. So we have 2 to the power of 2 times 3. It just tidies up the answer. Plus some exam questions will ask you to put it in index, your answer in index form. So 2 times 2 is 4. 4 times 3 is 12. So same answer, just tidies it up. So the next one I'm going to do is 10. I know 2 times 5 is 10. And I know that 2 of them numbers are prime. So I'm actually stopping here. So it's 2 in product form. 2 times 5. Easy, that one. Absolutely easy. Next one, let's do 24. 24. Still have branches. Now I'm going to go with 2 times 12 because I know the times table. We're going to stop on 2 because that's our first prime number. Now, again, I'm going to do 2 times 6. Stop on 2. It's a prime number. 2 times 3, which equals 6. And I'm going to stop there because 2 and 3, 2 times 3 equals 6. So I'm now going to put it into the product form, which is to multiply. So I'm going to put 2 times 2 times 2 times 3. And then I'm going to put it in index form to tidy it up. And I've got 1, 2, 3. 2. So I'm going to put 2 to the power of 3 times 3. There you go. Nice and simple. Nice and neat and tidy. Let's do another one. Let's do with 40. 40. 2 branches. I'm going to go 2 times 20. Stop there. That's a prime. I'm going to do 2 times 10. Stop there. That's a prime. 2 times 5. And stop there because once again, they're both primes. That's the end of the line. So now I've got 1, 2, 3 2s. 2 times 2 times 2 times 5. That's in product form. And now to go in index form, 1, 2, 3. That's 2 to the power of 3 times 5, which will equal 40. So there we go. Let's do another one. 75. So we're going to, what's 75? Well, I'm going to do 3, and 3 times 25 equals 75. So I'm going to stop at that 3. Now, what makes 25? 5 times 5 makes 25. And we can stop there because they're both prime numbers. So in product form, 3 times 5 times 5, which equals 75. Or in index form, it will be 3 times 5 to the power of 2. Let's do another one. Let's do 54. Got 54. What 2 branches can we put here? What makes 54? Well, I'm going to do 2 times 27. That can stop because that's a prime number. Is 27 a prime number? No, because I know that 3 times 9 makes 27. And 3 is a prime number, so we stop there. And I know that 3 times 3 equals 9. And we stop there because 3 and 3 are prime numbers. So in product form, to multiply, I'm going to put 2 times 3 times 3 times 3. Or tidy it up in index notation. So it'll be 2 times 3 to the power of 3. And they both equal 54. And one last one, I'll do 36. 2 branches there. I know that 3 times 12 makes 36. We can stop that there. We could do 2 times 6 equals 12. We can stop there. And then 2 times 3, and we can stop there and there. I just want to make a point here, actually, of showing it doesn't matter if you use different numbers to get the answer, you will still have the same prime numbers. So if, let's do 36 again, I asked in there. So 36, what other numbers could we multiply apart from 3 times 12? 36 is also 4 times 9. 4 is not a prime number, so we can take that to 2 times 2. And 9 is 3 times 3. Now we can stop. So this one has actually got 2 times 2 times 3 times 3, which equals 36. And then we're going to tidy it up. 2 to the power of 2 times 3 to the power of 2. And this one, which I've done differently, we equal that at 3 times 2 times 2 times 3. And simplify it, tidy it up, put it into index notation. There you go, exactly the same answers. So it doesn't matter if it's not the same working out to get the multiplication here, the 2 factors, it doesn't matter. So you might not have 3 and 12, but the guy is telling you it's 4 and 9. You can have 3 and 12, and he can have 4 and 9, because you will get the same answer. I hope that's helped.